Good day, everyone. Today, we are going to study about the inverse of a function. In solving for the inverse of a function, there is a procedure. For step number 1, we need to interchange x and y, meaning x will become y and y will become x. For step number 2, we need to solve for y or just simply isolate y. For step number 3, we need to change y into inverse of f of x. Let us have problem number 1. Problem number 1, we have y is equal to x minus 4. In step number 1, it is said that we need to interchange x and y. Y will become x and x will become y. Step number 2, we need to isolate y. To isolate y, we can transpose negative 4. So negative 4 will become positive 4, therefore we have x plus 4 is equal to y. Since y is already isolated, we can use the symmetric property of equality. So we have y is equal to x plus 4. And for the last step, we need to change y into inverse of f of x. So we have inverse of f of x is equal to x plus 4. And that is the final answer. For problem number 2, we also need to follow the procedure. Step number 1, we have x is equal to 2y plus 5. And we need to isolate y for step number 2. Transpose 5. So we have x minus 5. Since positive 5, when you transpose positive, that will become negative, is equal to 2y. Okay, notice that y has a numerical coefficient. So we need to divide both sides by its numerical coefficient, which is 2. So cancel 2. Then we have y is equal to x minus 5 over 2. And for the last step, we need to change y into inverse of f of x. So we have f or inverse of f of x is equal to x minus 5 over 2. For problem number 3, we have y is equal to 3x raised to 2 minus 4. And this one is an example of quadratic function but without its middle term. So we need to follow the same procedure. Step number 1 is to interchange x and y. So we have x is equal to 3y raised to 2 minus 4. The next step is to isolate y. Therefore, we need to transpose negative 4. So we have x plus 4 is equal to 3y squared. Since y squared has a multiplier or numerical coefficient, we need to divide both sides by 3. So cancel 3. Therefore, we have y raised to 2 is equal to x plus 4 over 3. Now, since y has an exponent, we need to cancel that. So to do that, we need to extract the roots. Extract the roots and extract the roots. Since we extracted a square root, we need to put positive and negative onto the other side. When we extract an even number of root, for example, square root, fourth root, sixth root, eighth root, we need to put positive and negative onto the other side. To continue that, we can cancel square root and squared. So we have y is equal to positive and negative square root of x plus 4 over 3. Since we already isolated y, we can change y into inverse of f of x. So we have inverse of f of x is equal to positive and negative square root of x plus 4 over 3. And that is the final answer. For problem number 4, we have y is equal to the square root of 3x minus 4. So to solve this one, same procedure, we need to interchange x and y. So we have x is equal to the square root of 3y minus 4. And notice that 3y minus 4 is inside the radical sign or inside the square root. So we need to cancel the square root. So to do that, we can raise both sides by 2. So x raised to 2, and this is square root of 3y minus 4 raised to 2. So cancel square root, cancel squared, x raised to 2 is x squared is equal to 3y minus 4. Since 3y minus 4 is not inside the radical sign, we can transpose 4 or we can just isolate y. So we have x raised to 2 plus 4 is equal to 3y. Since y has a multiplier or numerical coefficient, divide both sides by 3. Divide by 3, cancel 3. So we have y is equal to x raised to 2 plus 4 over 3. Since we already isolated y, we can change y into inverse of f of x. Is equal to x raised to 2 plus 4 over 3. And that is the final answer. For problem number 5, we have y is equal to x raised to 3 plus 8. This one is an example of cubic function without its second and third term. Same procedure, we need to isolate or we need to interchange x and y. So x is equal to y raised to 3 plus 8. So next step is to isolate y. We can transpose positive 8. So we have x minus 8 is equal to y raised to 3. And since y has an exponent of 3, we can extract cube root. Cube root on the right side and cube root on the left side. Cancel cube root, cancel cube. Therefore, we have y is equal to cube root of x minus 8. Since 3 is an odd number, we do not need to put positive and negative. Next, we need to change y into inverse of f of x. So we have inverse of f of x is equal to cube root of x minus 8. And that is the final answer. For problem number 6, we have y is equal to cube root of x raised to 2 minus 4. First step is to interchange x and y. So we have x is equal to cube root of y raised to 2 minus 4. And since we have cube root, just the same as square root, we need to cancel this one. So to cancel this one, we need to raise both sides by 3 since we have cube root. So raise to 3 and raise to 3 on the other side. Since we have cube root and raise to 3 or cube, we can cancel cube root and cube. Therefore, we have x raised to 3 is equal to y raised to 2 minus 4. On the second step, we need to isolate y. So therefore, we can transpose negative 4. So we have x raised to 3 plus 4 is equal to y raised to 2. Since y has an exponent of 2, we can extract square root. Since we extracted square root, we need to put positive and negative. So cancel square root squared. So we have y is equal to positive and negative square root of x raised to 3 plus 4. On the last step, we need to change y into inverse of f of x. So we have positive and negative square root of x raised to 3 plus 4. And that is the final answer. For problem number 7, we have y is equal to x plus 5 all over 2x plus 4. This one is an example of rational function. So first step, we need to interchange x and y. So we have x is equal to y plus 5. And notice that on the denominator, we have an x. So therefore, we have 2y plus 4. Next step is to isolate y. So to do that, you can do something like this. Multiply the denominator to the x. So therefore, we have 2xy plus 4x. Since 2y times x is 2xy, 4 times x is 4x is equal to y plus 5. Next, since we have 2xy and y onto the other side, to combine them, we need to put them on the same side. So transpose y and transpose 4x onto the other side. So we have 2xy minus y, since positive, when you transpose positive, that will become negative, is equal to negative 4x plus 5. Since 4x is positive, when you transpose that, that will become negative. 5 is still positive since we do not transpose 5. Next, 2xy and negative y has both y, meaning we can factor out y. So to factor out y, we have y is equal to, when you factored out y, 2x will remain. And when you factored out y from negative y, negative 1 will remain, is equal to negative 4x plus 5. Next, to isolate y, we can divide both sides by 2x minus 1. So we have y is equal to negative 4x plus 5 over 2x minus 1. Since we already isolated y, we can change y into inverse of f of x. So we have inverse of f of x is equal to negative 4x plus 5 over 2x minus 1. And that is the final answer. For problem number 8, we have y is equal to 2x raised to 2 plus 3 all over x raised to 2 minus 4. This one is also an example of rational function. So first step, we have x is equal to 2y squared plus 3 over y squared minus 4. Just like on the previous example, we can multiply the denominator to x. So x times y squared, that is xy squared. X times negative 4, that is negative 4x, is equal to 2y squared plus 3. For step number 2, we need to isolate y. Since we have xy squared on the left side and xy squared on the right side, we need to combine them. So transpose 2y squared, so we have xy squared minus 2y squared is equal to 4x plus 3. Since negative 4x, when you transpose that, that will become positive. Now, since we have xy squared minus 2y squared, we need to factor out y squared. So we have y squared times x minus 2 is equal to 4x plus 3. And after that, we can divide both sides by x minus 2. So x minus 2 is cancelled. So we have y raised to 2 is equal to 4x plus 3 over x minus 2. Since we have y raised to 2, we can extract the square root. So extract the square root, cancel this one and cancel the squared. Square root, put positive and negatives since that is square root. So we have y is equal to positive and negative square root of 4x plus 3 over x minus 2. So for the last step, we need to change y into inverse of f of x. So we have inverse of f of x is equal to the square root of 4x plus 3 over x minus 2. And that is the final answer.